Okay, class. So this is another discussion in thermodynamics. So actually, this is supplementary exercises to ideal gas. Okay, so there are several problems here answered. Okay, so let us consider this problem. Okay, so actually, this is quite a difficult class. So find the work process for a helium gas at 20 degrees Celsius. Okay, so this is in a form of a multiple choice question. Okay, so we have here the option for A 609, B is 168, C is 229, and D is 339 kilojoules per kilogram. Okay, so actually, if we do not know the molecular weight of the helium, we cannot answer this problem. Okay, so the most important is you have to know what is the molecular weight of the helium. Okay, so actually, the formula used here is very easy. Okay, so from the ideal gas equation or the equation of state, PV equals to MRT, where PV is equals to work. So that was already discussed, di ba? That is equals to MRT. So taking now the molecular weight of helium, which is equals to 4, and then from the equation, work over the mass is equals to RT. Okay, so work over the mass is equals to RT. So that is energy per unit mass. Substituting now the value of R, which is equals to the universal gas constant 8.314 over the molecular weight, is equals now to R for the helium, multiplied by the temperature of 20 plus 273. Therefore, the work per unit mass now is equivalent to 609 kilojoules per kilogram, where the answer is letter A. Okay? So, I think class, it is clear to everybody. Okay, so another example here. So, we have 2 kilograms of gas is confined in a 1 cubic meter tank at 200 kilopascal and 88 degrees C. Okay? What type of gas is in the tank? So, another difficult problem, class. Okay? All you have to do is memorize the molecular weight of every gas so that you can compare, of course, your answer. The calculated answer may be easy, but to tell what gas is present is quite difficult. Okay, again, class, the option is helium, B is ethane, C is methane, and D is ethane. Okay, so solution again, PB is equals to MRT, substituting values of 200, 1 cubic meter, and then 2 kilograms, and then molecular weight is, of course, or the gas constant divided by the molecular weight multiplied by the temperature of 88 plus 273. So, therefore, class, the molecular weight is equals to 30. Okay. So, looking at now the value of molecular weight for helium. So, helium, in the previous example, the value of the molecular weight is 4. So, which is wrong now. Ethane is in a form of C2, it's 6. So, what is C2? C is carbon. Carbon is 12 plus, multiplied by 2 is 24 plus 6. Molecular weight is 30. So, which is now the correct answer. For methane, so let us also consider the molecular weight of methane. So, first, you consider the chemical formula of methane, which is CH4. C is 12 plus H multiplied by 1 multiplied by 4 is only 16. So which is wrong also, class. Okay? And ethane or ethylene, that is C2, it's 4. Where C is 12 times 2, 24 plus 4 is 28. So therefore, class, the answer is ethane, which has a value of 30. Okay? The molecular weight. Okay? So another difficult problem, class. Okay? But once you know the molecular weight, is very easy. Okay? Or the chemical formula. So because in molecular weight is very easy if you know the chemical formula. Okay? Next, class, we have here number 3. Find the enthalpy of helium if its internal energy is 200 kilojoules per kilogram. So this is, class, another quite difficult example, okay, or problem. So the option is 144, B is 223.42, C is 333.42, and D is 168 kilojoules per kilogram. Again, getting R for helium. So knowing the universal gas constant over 4, that is equals to 2.0785. And knowing, so from the table, obtained from the table, class, the value of K is 1.667. Okay? So actually we can solve this directly. So but we have a value of 2.0784 R. Okay? Where Cp is equals to Kr over K minus 1. So we have already K and R. So the value, substituting values for Cp is 5.195 kilojoules per kilogram Kelvin. And Cb, substituting again, just eliminate K at the numerator. So the value is 3.116 kilojoules per kilogram Kelvin. Okay? Where the ratio, class, of Cp over Cb is just equal to K. So actually, okay? Okay. So, but delta H, again, in our previous discussion, that is equals to mCp delta T. And also delta U, whether you like it or not, that is always equals to mCb delta T. Okay, so getting now, class, the ratio of delta H and delta U. So delta H over delta U is equals to mCp delta T over mCb delta T. Okay, eliminating mass and delta T. So that is now, class, equals to Cp over Cb equals to K. So therefore, delta H now, class, is equals to K delta U. Okay? So we already know what is K. Okay? That is obtained from the table. So delta H now, class, is equals to 1.667 multiplied by 200 is equals to 333.4. That is now the answer, class. Okay? So, but actually, you can solve this in a short manner. Okay? So, okay, class. Another example, we have here, number 4. So, compute the mass of 2 cubic meter propane at 280 kilopascal and 40 degrees C. Okay? So, class, again, without knowing the molecular weight, we cannot answer this problem. Okay? Okay. So, for propane, C3, it's 8. So, carbon is 12 times 3 is 36 plus H is 1 multiplied by 8 is 8. That is equals to 36 plus 8 equals to 44. Okay? Again, PV equals to MRT. So, getting now the mass, substituting values, mass of the propane is equals to 9.47 kilogram. Okay, so you know already, class. So, how you are going to solve this kind of problem. So, first, know what is the molecular weight. And then, substitute values from the equation of state or PV equals to MRT, and then get the unknown parameter. Okay? So, another class we have for number 5. An ideal gas at 0.8 atmospheres and 87 degrees C occupies 0.45 liter. Okay? How many moles are in the sample? Okay? So, knowing that R is equals to 0.08 to 1 liter atmosphere per mole Kelvin. Okay? So, the option class is 0.002, B is 0.0378, C is 0.0122 mole, and 0.0091. Again, solution, PB equals to nRT. So, direct substitution, we can easily get the value of N. So, substitute 0.8 atmosphere, and then 0.45 liter, 0.0821, and then 87 plus 273. Therefore, N now equals to 0.0122 mole. Okay? So, this is class very easy. Okay? Unlike in the previous example. Okay? So, another class we have here. So, this is actually number 6 rather. A certain gas at 101.325 kilopascal and 110 degrees C, whose volume is 2.83 cubic meter, are compressed into a storage vessel of 0.31 cubic meter capacity. Okay? Before admission, the storage vessel contained the gas at a pressure and temperature of 137.8 kilopascal and 26 degrees C. After admission, the pressure increased to 1171.8 kilopascal. What should be the final temperature of the gas and the vessel in Kelvin? Okay, so this is quite difficult, class. So, option is 298, 319.8, 180, and 314.2 Kelvin. Okay? So, we have here now, class, the solution. Mass of the gas to be compressed. Okay? The pressure is 101.325 and the volume is 2.83, and M1, of course, unknown, and the gas is also unknown. So, the temperature is 10 plus 273, therefore, the mass is 1.01325 over R. Okay? So, another, for the mass of the gas initially inside the vessel, so because the vessel was already filled with a certain gas or a gas before it was filled with another gas, okay, or the same gas rather. Okay, so solve for M2, since we have the condition for a pressure of 137.8 before it was filled with another amount of gas. So, and then 0.31, of course, is the volume, and mass of 2 multiplied by R, and the temperature is 26 plus 273. Therefore, the mass of the gas at 2 is 0.14286 over R. Okay? So, knowing, class, that mass of the final mass or the mass 3 is equals to the combination of the first mass and the second mass. Okay? So, mass 3 is the final mass. Or M3 is equals to 1.156 over R. Substituting now this class to PB equals to MRT. And the final pressure of 117.8, and again, a volume of 0.31. Okay? So, mass is 1.156 R over R multiplied by R will be cancelled out. And T3 now, therefore, is equals to 314.2 Kelvin. Okay? So, this is, class, a matter of understanding the problem. Okay? So, just relax in solving this kind of problem. Okay? So, thank you very much, class. So, that ends my presentation. Thank you.